Hello everyone, this is Technical Avant-Garde. Welcome back to our Arduino series. Today we will be doing something different. We had done till date, we had done our important questions to do the Arduino series, and the important questions one should know about the Arduino. Then we turned on and off the LED, then we blinked that the same LED. We blinked also the external LED as well as the onboard LED. Then we had discussed some technicalities of the breadboard. Then we used the command analog write, and today we will be doing the voltage divider. Yeah, this is the easiest part, but one should know what is voltage divider. So before moving into the mathematical part of the voltage divider, I want to tell something about the voltage divider. Voltage divider circuits are used to produce the voltage levels for a common voltage source, but the current through the schematic through the circuit will be the same for all the components connected in series, and the supply voltage can be positive or can be negative. Here in the schematic you can clearly see that Vs is the source voltage, which is the common voltage for R1 as well as for the R2 resistors, and VR1 and VR2 are the voltages for the respective resistances R1 and R2. Furthermore, voltage dividers are also known as the potential dividers, and as they give the amount of the potential difference between the 2 points. Like if you want to have the VR1 voltage, which is the voltage across the R1 resistor, then you must have the difference of Vs and V0. And Vs and V0 are the two points which are across this R1 resistance, and the voltage or the potential divider is a simple passive circuit that takes advantage of effect of voltages being dropped across components which are connected in series. This is the definition of the voltage divider. Here we are using the resistor voltage divider as we are dividing the voltage with the help of resistors. Now we will do some technicalities or the mathematical operations of this schematic, or this demo schematic, I must say. Yeah, Vs1 is equal to VR1 plus VR2 with the help of Kirchhoff's voltage law, and the VR1 is equal to R1 into the current flowing through the R1I, and again VR2 will be the same, I into R2. Vs is equal to I into R1 plus I into R2. Therefore, the total source voltage is equivalent to I R1 plus R2. Then the series current flowing through the schematic is Vs by R1 plus R2. And then if you want to find the voltage VR1 and VR2, and you know that IR1 is equal to IR2 is equal to I, so you can clearly find VR1 and VR2, which is equivalent to the source voltage divided by the resistance. You want to find the voltage divided by the total resistance. So VR1 is equal to Vs by R1 plus R2, and again VR2 is equal to Vs by R2 by RT, or you must say total resistance. This is the example we will be doing to explain more on voltage divider or the resistor voltage divider, and we will be doing simulation for the same schematic. We have the source voltage 36 volt and 3 resistor connected in series with 6 kilo ohm, 12 kilo ohm and 18 kilo ohm resistances. So this will be the mathematical part to explain, that is the total resistance is equal to R1 plus R2 plus R3, which is equal to 6K plus 12K plus 18K, which will be 36K, and the series current flowing through the schematic is Vs by RT as per the Ohm's law, and which is equivalent to 36 by 36K. So the current flowing through the schematic is which will be the series current, which is equivalent to 1 milliampere, and the the voltages across each resistances is calculated by the same formula we had defined, which is equivalent to the source voltage into the resistance. You want to find the voltage divided by the total resistance, which is equivalent to Vs into R1. Vs into R1 divided by RT is equivalent to the VR1. So We had calculated the resistance VR1 6 volt, VR2 12 volts, and VR3 18 volt. Now we will define or calculate all these voltages and the current, series current, using the simulation of the same schematic, simulation of this schematic on the LTSpice software, which is the free simulation software which can do the AC simulation as well as the DC simulation. So let's begin with our simulation part. So yeah, this is our LTSpice XVII, and I had already made the schematic for you people. I had given the 36 volt as the source voltage, then 6 kilo ohm resistance, then 12 kilo ohm resistance, then 18 kilo ohm resistance. Now I'll be calculating the voltage at node A, B, and C. I don't think C will give any voltage, so I'll run this schematic and it will give you, yeah, here you can clearly see that at voltage at A is 36. Like we are giving the voltage source with the we are providing the voltage from the voltage source V1, which is equivalent to 36 volt, and the voltage at A is equal to approximately 30 volts. So the voltage drop at R1 is equivalent to 6 volt, which we had calculated in our calculation part. If you want to see again, then you can go back in this video, and if you then at voltage at B is equivalent to 18 volt, 18, approximately 18 volt. So voltage at A is 36 and voltage at B is 18 volt. So voltage drop at from the R2 through the R2 is 12 volts, because if you will subtract the voltage at A, because voltage at A is at the higher potential and voltage at B is the lower at low potential, because there is a potential drop at through the 12 ohm resistance, 12 kilo ohm resistance. So the voltage drop at through the resistance R2 is the 12 kilo ohm, and at voltage at C is approximately 0, because it is connected to the ground part. So the voltage at B is 18 volt, and voltage at point C, or voltage at node C, is 0 volt. So the voltage drop through the resistance R3 is equivalent to 18 volt. Now I'll show you, and you can clearly see that IR1, IR2, and IR3 and IV1, the current through all the schematic is equivalent to 1 milliamps. You can clearly see that this is 0.00099 is the 1 milliamp. Now I'll show you all this. This is the calculation part done by this simulation software. Now I'll show all these values through the graph. Now here you can clearly see the graph. I'll drop the probe. Here, here, and here, which will give you the exact voltage at the node. So first I'll drop here. It will give you the 36 volt, because the voltage coming out from the voltage source is 36 volt. You can clearly see that it is the 36 volt. Yeah, then I'll drop the probe at node A. It is giving that it is equivalent to 30 volts. You can clearly see that it is approximately 30 volts, because the resistance is a little bit more than 6 kilo ohms. Then I'll drop the probe at node B. You can clearly see that it is the 18 volt, approximately 18 volt. You can clearly see that the voltage at this node, which is given by the software, which is N001, which is 36 volt. This is your 30 volt, then this is your 18 volt, and this is again your ground, which will not given by the software. So you can clearly see that all these voltages are divided. 36 voltage is divided into R1 and R2 and R3 resistances respectively. So you can you have the calculation part as well as the simulation part done by the software. Now you if you want to see the current, series current flowing through this schematic, is you can clearly see This is the 1 milliamps, approximately 1 milliamps given by 0.0009. Yeah, this is the 1 milliamps, which is the series current. Yeah, that's it for this lecture. This is the voltage divider done. I had explained you in the mathematical terms as well as in the simulation term. Thank you for watching this lecture. If you found this lecture interesting, then please let me know in the comment section, and do hit on the like button. And if you haven't subscribed this channel Technical Avant-Garde, then do subscribe to the channel. You will find a lot interesting technical things in future. And if you have any doubt regarding any lecture, please leave your doubt in the comment section, and I will definitely respond to your doubt. Stay safe, stay happy, meet you in the next lecture.